Hello. Now we're going to look at two proportion tests. So if we have two proportions, we have two different sets of proportions, sample sizes, and sample proportions, which is our p hats. So now we'll use those to talk about what happens when we take the difference of proportions. So if we want to find the sampling distribution if we take the difference of the two proportions, the center is just going to be the two subtracted with each other. The spread, we can do some mathematics from, this is just kind of leading to where we need to get to on how we get our new equation. And then we take this new equation and we do another step, and I'll do that in the next page. But once the samples are large, then the sampling distribution is approximately normal. That describes a shape. Now the spread, we actually need something called a combined p. This is using a pooled sample, where when we were using t-tests, I told you not to use a combined p for two sample t-tests, but we do a pooled for proportions, which means we take our x values, so the amount of successes, add them up all over how many our n's added up, and we call that a combined p. And to test any our significance tests with two proportion tests, we we're testing that the two proportions are the same. And if that's the case, this is how we find our z. We subtract our two p hats on top, and then we use our combined p times 1 minus combined p times 1 over n, first n plus 1 over the second n, the square root. This is just our standard error for two proportions, this bottom. So you're kind of doing the same thing you did before. You subtract two values over your standard error. All right.